Tests for copper 2 ion. Copper is a chemical element with the symbol Cu. It is found in many salts like copper sulphate, copper chloride and copper carbonate as copper 2 ion. In group 2, copper 2 ions are precipitated as their sulphides by passing hydrogen sulfide gas through their solution. Our aim here is to test the presence of copper 2 ion in a given salt. First, we look at the preliminary tests of copper 2 ion. Dry heating test. Materials required: original salt, test tube holder and Bunsen burner. Procedure: take a small quantity of salt in a test tube. Heat it over the Bunsen burner. The salt becomes brown on heating, indicates the presence of copper 2 ion. Charcoal cavity test. Materials required: mixture of salt and sodium carbonate, charcoal piece, distilled water, dropper, tongs, blowpipe and Bunsen burner. Procedure: take a mixture of small quantity of salt and double its quantity of sodium carbonate in a watch glass. Take a charcoal piece with small cavity in it. Using a spatula, take a small quantity of the mixture and place it in the cavity of the charcoal piece. Using a dropper, add few drops of distilled water to the mixture to moisten it. Hold the charcoal piece in front of the reducing flame of the Bunsen burner using tongs. Now, direct the reducing flame on the cavity by means of the blowpipe and heat strongly for some time. Red beads or scales indicate the presence of copper 2 ion. Flame test. Materials required: original salt, concentrated hydrochloric acid, dropper, glass rod, platinum wire loop and Bunsen burner. Procedure: take a small quantity of the salt in a watch glass. To this, add a few drops of concentrated hydrochloric acid using a dropper. Mix the contents of the watch glass using a glass rod to make a paste. Take a small amount of the paste on the platinum wire loop and introduce it into the oxidizing flame of the Bunsen burner. Bright bluish green flame indicates the presence of copper 2 ion. Borax bead test. Materials required: original salt, borax, platinum wire loop and Bunsen burner. Procedure: take a small quantity of borax powder in the loop of platinum wire by dipping it in borax powder. Heat it in the flame of the Bunsen burner. Borax swells and forms a transparent colorless glassy bead. Dip the hot bead in the watch glass containing salt. Heat it again either in the oxidizing flame or in the reducing flame of the Bunsen burner. In oxidizing flame, the color of the bead becomes green when hot and light blue when cold. In reducing flame, the bead becomes colorless when hot and opaque when cold. Next, we look at the analysis of copper 2 ion. Materials required: salt solution in a test tube, dilute hydrochloric acid, hydrogen sulfide gas, 50% nitric acid, dilute sulfuric acid, distilled water, alcohol, ammonium hydroxide and water bath. Procedure: take a small quantity of dilute hydrochloric acid using a dropper. Add it into the test tube containing a small volume of salt solution to acidify it. Now, pass the hydrogen sulfide gas through the solution. Copper 2 ions present in the salt solution react with hydrogen sulfide to form black precipitate of copper sulfide. Transfer the precipitate into a centrifuge tube to separate it by centrifugation. Now, add a small quantity of 50% nitric acid to the precipitate in the test tube and heat in a water bath. Copper sulphide reacts with nitric acid to form soluble copper nitrate. To this solution, add a small quantity of dilute sulfuric acid using a dropper. Using another dropper, add a small quantity of alcohol to the solution. Now, add excess of ammonium hydroxide solution to it. Copper ions react with sulphate ions in the solution and excess of ammonium hydroxide to form a glue-colored tetramine copper 2 complex. Finally, we look at the confirmatory tests of copper 2 ion. Potassium ferrocyanide test. Materials required: solution obtained in the group analysis, acetic acid, potassium ferrocyanide solution and droppers. Procedure: take a small quantity of acetic acid using a dropper. Add it into the test tube containing blue solution obtained in the group analysis. The tetramine copper 2 complex reacts with acetic acid to form soluble copper sulphate. Now, using another dropper, add a small quantity of potassium ferrocyanide solution to the test tube. The copper sulphate reacts with potassium ferrocyanide to form a chocolate brown precipitate of copper ferrocyanide. Potassium iodide test. Materials required: solution obtained in the group analysis, acetic acid, potassium iodide solution and droppers. Procedure: take a small quantity of acetic acid using a dropper. Add it into the test tube containing blue solution obtained in the group analysis. The tetramine copper 2 complex reacts with acetic acid to form soluble copper sulphate. Now, using another dropper, add a small quantity of potassium iodide solution to the test tube. A white precipitate is formed in brown-colored solution because the copper sulphate reacts with potassium iodide to form white precipitate of copper iodide and brown solution of iodine.